Now we're going to use data table command to generate the replications. In the previous file, we looked at replications as just copying the model 1000 times or however many number of times that we needed. But now we're going to generate the profits using the data table approach. So we will have the model as just one single row. It's the same problem. So let's set up the lookup table. So remember, we need to start with 0 as the cumulative probability, and then that previous cumulative probability plus the probability of the previous row, and we copy that for the rest of the rows. Lookup table, let's define a name here. Lookup table, and let's give names for these. Okay, now let's set up the model. So demand. Okay, so here it will be VLOOKUP, and we're going to do the rand function nested in. That's the probability. Then our lookup table, comma 2. That's the demand. Now, sales in units is the minimum between order quantity. Okay, we didn't give a name for that. Let's give a name. So minimum between order quantity and demand. So return is order quantity minus sales. Revenue is sales times unit price. Cost is order quantity times unit cost. And refund is return times the unit refund. So then profit is revenue minus cost plus the refund amount. Okay, and that's the profit. Now we want to replicate and generate 1000 replications of the profit. So we can generate a data table for that, with the first row being the profit. Then we will do replications. Well, let's go all the way down and fill series up to 1000. So now that generated 1000 replications. Okay, so now let's do a data table. Okay, so 1000, and all we have to do here is go to data, what if analysis data table, and the replications are in a column, so select column input, and now what we have to do is to simply select one of the blank cells. It has to be a blank cell as the input cell. Okay. Now click OK, and that will generate the profits for you on replications. Now they're all 500 here. That's because we have to recalculate these cells. Then only the different profits will occur. So what will happen is, in the data table command, the data table will take each value here in this column and enter it in this cell, and that will force a recalculation of everything. And so the rand will get recalculated and everything will get recalculated because of that, and then the different profits will show up. Now for that we have to go into File Options, and under Formula you have to make the proper selection. Right now the recalculations is automatic except for data tables. So data table is not going to automatically get recalculated. So you have to select the automatic, or if you want to keep it as automatic except data table, then you have to press the F9 key to force a recalculation. Okay, so we'll use that in a little bit, but if I select automatic, then you see automatically everything gets recalculated and you see the different profits. Now if you have, and sometimes it's convenient to keep the recalculation to automatic except data tables, because if you have a large Monte Carlo simulation, every time you make a small change, and if your data table is going to get recalculated, you have 1,000 replications or even 2,000, 3,000 replications, it can be really annoying, and because there will be a lag between you making a change and getting the control back. So it is convenient to select this, but of course when you do that, then you have to make sure that after you do something, then you have to press the F9 key so the recalculation occurs. So F9, depending upon how you set up the auto recalculation, you have to either press the F9 or not. Okay, now that we have the replications done using data table, let's go ahead and name this, and we will generate the confidence interval. Let's name replication 1 to 1000. Use define name. Profit, say let's call it reps or replications. Reps standing for replications. Okay. So then average standard deviation is stdev.s. Minimum profit, maximum profit, and then replications count, and standard error is standard deviation divided by square root of the number of replications. Okay, now the confidence interval, we want 95% confidence interval. So for the T table, the lookup value is 1 minus the 95%. So we have now T.inv.2t, 5% the lookup probability, and the degrees of freedom is n minus 1. Margin of error is the T value times standard error, and average profit minus margin of error will give you the lower limit, and average profit plus margin of error will give you the upper limit. Okay. So our interpretation is we are 95% confident that the average profit for order quantity of 200 will be between $181.62 and $222.13. Okay. So this is the same model like the previous one, except this time we are generating the replications using the data table. Now, there is one more issue here, and that is how many replications should we run? Now we selected 1,000, but why 1,000? Why not 500? Or why not 5,000 replications? So how do you determine the number of replications that we have to run? So let's look at that in the next video. Okay, the number of replications that we have to run can be determined using the sample size formula. So here the formula is 4 times, okay, this is an approximate value. It tries to overestimate rather than underestimate. So we really need to be using t-value here, but 4 is a good approximation. And then standard deviation that we find from the replications, square that and divided by b squared, where b stands for the margin of error. How big a margin of error you want to allow. Okay, of course, smaller the margin of error, the larger the replications will have to be. So we can use this formula to figure out how many replications you should run. So let's look at let's go back to the Excel file and then look at the example. Okay, so here is the formula. Suppose we want to estimate the expected profit from the calendar sales. So right now, when we ran for 1,000 replications, the margin of error turned out to be about $20, so on the plus or the minus side. Suppose we want the margin of error to be no more than $10. We want to estimate the profit within a $10 margin. Then the number of replications we have to run is 4 times the estimated standard deviation. So here is the standard deviation of profit. You square that. Okay. Divide by the margin of error, and that should also be squared. So that gives us 4,262 replications. Now you want it within $5, then you have to run 17,000 replications. Or if you're willing to allow $15, then about 1894 replications must be run. So this is how you will determine the number of replications you have to run so that you can estimate your profit, within a desirable range given by the margin of error.